Okay, so like I said, there's one of these already in your notes, but here we go again. This is about a fox population. It has a growth rate of 9% per year. 2012, there were 23,900 fox. What's the population predicted to be in the year 2020? So they never told us anything about continuously or anything like that. So we're just going to use a basic exponential where we need A, the initial, and B, the rate. So the initial population was 23,900. The rate is 9%, but remember, anytime we have our rate, in order to get B, which is that value, it's going to be equal to the rate plus B if it's growth, or, sorry, that's not right. It's going to be equal to 1 plus the rate to get B if it's growth, or 1 minus the rate if it is decay. And so this is going to be growth. They told me that. So we're going to take the 1 plus the 9%. So we have 1.09 raised to the t power. We change the 9% into a decimal like that. So now we can go ahead and figure out what the population is by putting in a value for t. Our value for t is 8 years later, so we're going to put that in for 8, and then you can go to your calculator and put this in your calculator. Unfortunately, I'm doing this at home, and I don't have my calculator, and I'm using my phone to record because I could never get my smartboard to work, and no one ever showed up to tell me, so it is what it is. So in 1985, a house was worth $1,010, and in 2005, it was $1,045, and they want to know what is the annual growth rate between these two. And again, I did this one in the notes already once, so you can see the work from this if you wrote it down. So we're not talking about continuous growth or anything here, so we're going to use this formula again. This is going to be our initial value stuff. So A is worth equal to that. We don't know what B is. That's what we have to find. That's what they tell us to find. So we're going to use this other information to plug this in and figure out what B is. So our final value is 145,000. We don't know what B is, and T is the number of years elapsed, which is 20. So to solve this, we're going to divide both sides by 110,000. So we have B to the 20th equals whatever this is, which I can cross off the zeros without my calculator. I don't know what that is, though. And then to move the 20th power to the other side, we're going to take the 20th root, and I showed you how to do that on the calculator. Oops, extra 1 there. Trying to hurry, because if these videos are too long, then all heck breaks loose. So this is going to end up being 1.0 something 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 equals B. Again, this is B. They want to know the rate. So since this is growth back up here, in order to get R, I'm going to have to do whatever this value is and subtract 1. And then you'll get your 0.0000 whatever it is. And that's equal to R. And then to convert that to the percentage, you have to move that decimal over. And again, I explained all that in class when I did this problem originally. So hopefully you can look back at your notes and figure that out. All right, number 65. This person wants to save $54,000. Whoops, extra 1 there. For a down payment on a home. He wants to know how much he should invest if the account is 8.2%, compounding daily, to reach his goal in 5 years. It's going to have to be a lot of money, I can tell you that. So the compounding daily was the key. Tells me to use this formula. This is what he wants his final amount to be. He's asking for his initial amount, so we don't know that value right there. So his final amount is 54,000. We don't know P. R is 8.2%, but we're going to change that to a decimal. N is its compounding daily, so 365 raised to the 365 times 5 years. So to calculate this, we need to get P by itself. Well, P is being multiplied by all of this. You can put this in your calculator and get some number. You can do 0.082 divided by 365 plus 1 raised to this power, get some number there, and then you have a number times P. And then to get P by itself, you divide by that number, and then that gives you how much he needs to invest. For 67, we're going to open a retirement account with this amount in the year 2000. Her initial deposit is $13,500. How much will it be worth in 2025 if it compounds monthly? Or continuously? So if we're going to compound monthly, we're going to use this formula. And if it compounds continuously, we're going to use this formula. For monthly, we're going to invest $13,500. That's going to be my principal. Over here, same thing, still $13,500. Next, I need the rate, which is 0.0725. Next, I need the rate, which is 0.0725. Next, I need how many times it compounds. Monthly is 12. Next, I need the time. The number of years elapsed here is 25. Next, I need the time. The number of years elapsed here is 25. Again, you put this in your calculator. E to the 0.025 times 25 times 13,500. And over here, again, get this and then multiply by that.